So this is related to one of the next labs, but we're going to go over it today, and we're going to add this to your foot pressure lab. So we're continuing our examination of pressure, and particularly we're going to be looking at air pressure with this demonstration. So what I'm going to do is I'm going to be taking these, these are just suction cups, and I'm going to be pressing down on this one here, and I'm going to seal that. I'm going to do the same thing with this one over on the other side. I'm going to push it down. So I've created a nice seal with this. So what I'm going to do now is I'm going to try to lift my desk. This is the desk that sits in front of the class. Okay, so I lifted the desk. The desk is extremely heavy, and I lifted that using these suction cups. So the question is, what actual weight can these things lift? What's the force that would be required to lift these things up like that? Okay, so I have enough force to do that, but what is the actual weight force? And we can also see what is that in terms of pounds that it can lift as well. So that's the question we're going to address, and this is going to be the orange discs. So the orange discs we're going to be talking about. So I'm going to draw this over here. You can also do the same thing with these, and we can push them together like this. And try to pull them apart. Can't do it, okay? I physically can't do it. And this is the reason why. You wouldn't be able to do it either. So don't think you can. Okay, so what is creating all of this pressure? So if you imagine these two orange discs that are side by side and they've been pressed into each other, what has happened is we've squeezed all of the air out of between the suction cups. So what we've done is we've created on the inside, since we've squeezed all the air out, there is no air. We've created a vacuum. A vacuum is on the inside of that, and that's going to be 0 kilopascals. So what we have is, on the outside from every which direction, we now have 101.3 kilopascals, which is just air pressure. But that's actually pushing in now because pressure is going to be going from high to low. So at the 101.3 kilopascals, how much force is needed to rip those things apart? And that's what we're going to calculate. So first we're going to start with that 101.3 kilopascals. Kind of step one, we have 101.3 kilopascals. So of course, this is going to be converted into pascals. We're going to be multiplying by 1,000. We now have 101,300,000 pascals, which is going to be equal to 101,300,000 newtons per meters squared. So this is where we're going. We can measure what the area is of our disk, and then we'll be able to calculate the force that's required to rip those apart. So let me go ahead and get these disks. Okay, I've broken the seal. What we're going to do now is we're going to measure in centimeters what is the area of this. Okay, this comes out to be about 11.4 centimeters. So the area of my disc going across, the diameter actually would be 11.4 centimeters. So if you remember the formula for area, area is equal to pi r squared. So when you get the radius, so this is going to be equal to pi times the radius half of 11.4 is going to give us 5.7, and that's going to be centimeters squared. So if we square that, I would suggest you guys really do this at home to get the practice. Okay, and you guys should get 102 centimeters squared. This is centimeters, but we need to get it into meters.